Yeah. Oh, there it goes. They got it. Thank you. So, Johannes Kepler is my intellectual hero. The great late historian of astronomy and astronomer, Owen Gingerich of Harvard University, once said that once you're pulled into the orbit of Johannes Kepler, it's impossible to escape. And I could not agree with that statement anymore. Johannes Kepler was obsessed with the concept of harmony. And that probably surprises a lot of people because when you hear the word harmony, you often think about music, right? It's the first thing that comes to mind. But Kepler was obsessed with the concept of harmony as it applied to every segment of reality. And I'm going to talk about one particular way he saw harmony applying to the material world today. So the topic of my talk today is on what I call the miracle of cosmic comprehensibility. And when I say cosmic comprehensibility, I mean something very specific. The uncanny resonance between mathematics, the material world, and the human mind. So mathematics, matter, and mind existing in harmony. It turns out that this harmony is exactly what makes the scientific enterprise possible. First of all, it turns out that for the cosmos to be, we can say comprehensible, we could say intellectually transparent, we could say intelligible, are these three domains existing in what I'm calling an uncanny harmony. So it's this harmony of phenomena that have no causal connections between them. And I'm going to say a lot more about that as I go on. And this demands what I'm calling a unifying metaphysical explanation, not, mind you, a scientific explanation. And number two, the second part of my thesis today is that this comprehensibility of the material world powerfully implies that humankind, we, occupy an exclusive place of significance in the cosmos. So I'm a big nerd about intellectual history, and I could give you an entire course on the history of this idea that I'm calling cosmic comprehensibility, but for the sake of our time today, I'm going to give you a very brief history of the idea. It'll be a quick flyover tour, if you will, of how this idea can be traced all down through what we call the Great Western Tradition. This is Pythagoras of Samos. He is our most famous of what we refer to as the pre-Socratic philosophers, the philosophers who lived and did their work prior to Socrates. And we don't know a whole lot about the original teachings of Pythagoras because he was an oral teacher. He didn't leave behind any writings that we know of. So everything that we think we know about Pythagoras is contained in existing manuscripts of later philosophers who referred to themselves as Pythagoreans or who were part of what was called the Pythagorean school of philosophy. But one thing we can be really confident about when it comes to Pythagorean thought is that Pythagoras believed that number was somehow fundamental to all of reality. And he included material reality in that statement. So number is the essence of the cosmos, and human beings are part of the cosmos. So in some mysterious way, number underpins everything, including the minds of human beings. I love this particular artistic rendering of Pythagoras because there's so many different items in the image that we commonly associate with him. So if you look down to the left, you'll see some sort of stringed musical instrument, probably a lyre or some sort of harp. And we often associate that with the Pythagoreans because they developed the mathematical theory of harmonics. And then over to the right, you see the little checkered squares. Those represent what all of you learned about in middle school, the Pythagorean theorem, and so on and so forth. Above Pythagoras' head, you see a triangle with 10 little tick marks in it. I don't know if you can see that from where you're sitting. But that represents the number 10, or what they called the tetractys. And they believed that the number 10 was actually divine. And so you'll often see the number 10 represented in some way when the image is related to Pythagoras or the Pythagorean school. Pythagorean thought was really disseminated through the great Western tradition through the work of Plato, a far more famous and more well-known among average folk philosopher. And it's often been said that all of Western philosophy since Plato has simply been footnotes to Plato's work. And I think there's a lot more truth in that than most people actually realize. Plato wrote a dialogue called the Timaeus. How many of you have actually read at least portions of the Timaeus? Anyone here? One? Okay, good. Well, that's your homework after today, is to get a copy of the Timaeus. This is probably, I think it's his most difficult, so that's not very encouraging, right? His most difficult dialogue. But it is in the Timaeus that Plato gives this thoroughly Pythagorean account of how the cosmos came to be and why it's orderly and beautiful. He says that there is a divine craftsman, and this divine craftsman used an eternal, immaterial, rational plan. Plato referred to these as the forms. This is where we get his famous doctrine of the forms, which he also talks about in other dialogues, such as the Republic. Our cosmos is mathematically ordered and harmonious, and this harmony and order is reflected in the soul of man. So what I hope you're already seeing is the Pythagorean thought that has infused Plato's work here. This idea of there being mathematical rationality behind all things, and the mind of human beings being attuned because we also are part of this rational cosmos. Now, we're going to fast forward just a little bit to this guy. This is Philo of Alexandria. So here's where we see what I'm calling the Pythagorean Platonic tradition becoming fused with Judean monotheism. So Philo of Alexandria, he was a Jew. He was also what we call a Middle Platonist. And he's someone who's very often read in theology and philosophy classes. He was hailed as one of the most remarkable literary phenomena of the Hellenistic world. And Philo of Alexandria was very well educated in Greco-Roman thought, and he agreed with Pythagoras and Plato. And he said, yes, there is a rational plan for creation, but it pre-existed in the mind of God rather than what we might call a Platonic heaven of abstract forms. He went on to say that the divine reason, or God's rationality, the mind of God, is made manifest in the material creation, including the mind of man. And this is related to the doctrine of the imago Dei, or God being made in the image, man being made in the image of God. Fast forward just a little bit more, we come to the fusion of the Pythagorean Platonic tradition with Christianity. This is my favorite artistic depiction of St. Augustine of Hippo, arguably the most influential theologian of Western Christianity. And he followed in Philo, Plato, and Pythagoras' footsteps. Interesting that they all begin with a P. That's fun for me, because I'm just that nerdy. He said, yes, there was a mathematical, rational plan for the created world, and it has existed from eternity in the very mind of God. And for those of you who are art lovers out there, this particular painting is by Botticelli, and it is fabulous. And that brings us to Johannes Kepler. Clearly, I've skipped a whole lot of Western intellectual history to come to Kepler, but if you're interested in all the things that come in between, then you need a copy of my book, Thinking God's Thoughts. And if you recognize that particular phrase, you'll find out why in just a minute. So Johannes Kepler was, by all accounts, what we could call the intellectual culmination of the Pythagorean Platonic tradition. And he is nearly singularly responsible for transforming ancient astronomy into a sophisticated theoretical science. As I said from the outset today, he was obsessed with this concept of harmony, or the fitting together of disparate parts, and that pervaded and motivated his entire life's work. Kepler was a devout Lutheran Christian, and he was a Protestant at a time when it was actually very difficult to be a Protestant Christian during the era of the Counter-Reformation. He was actually buried during the 30 Years' War, and as a result, we actually have no idea where his grave is because his tombstone was destroyed in a battle associated with that war. So he was convinced that the universe operated according to harmonious mathematical laws, and that these mathematical laws have subsisted from eternity in the mind of the maker. And so we can identify a certain, what I would call a natural theology with the thought of Johannes Kepler. And I'm going to show you a diagram that maps that out a little bit for you in just a moment. But Kepler, as I said, really is the pivotal figure in the scientific revolution who transformed astronomy into a theoretical science. He is most famously known for his 3 planetary laws, the first law being that planets orbit the sun in an ellipse and not circle, as Aristotelians had believed, and you see that the sun is slightly off center within the ellipse. These diagrams are actually pretty exaggerated, just so that you get a good idea of what's going on, but the ellipses are actually not this pronounced, just so you know. Second law is that as a planet revolves around the sun in its planetary year, it sweeps out equal area and equal time, meaning that no matter how short the distance in its revolution around the sun, it's sweeping out an equal area in an equal amount of time, and that's what those blue triangles there represent. So the reason for the difference in the duration along the perimeter of each one, the orbital period we call it, is because the closer a planet is to the sun, the faster it moves because of the gravitational pull of the sun. But even so, when an equal amount of time goes by, an equal area has been swept out within the ellipse. And then the third planetary law is a little bit more complicated. It simply says that the square of the orbital period, again, the orbital period being the one revolution around the sun, if you square that number, it is directly proportional to the cube of that planet's what we call the semi-major axis, which in layman's terms is just the mean distance from the sun. So I'm showing you these because I just wanted to really hit home with you the extent to which Johannes Kepler mathematized astronomy. I want to give you a few quotes from his famous work, and then also a quote from a letter that he wrote to an associate. So I'm going to start with the letter, and here's what Kepler wrote. To God there are in the whole material world material laws, figures, and relations of special excellency and of the most appropriate order. Those laws are within the grasp of the human mind. God wanted us to recognize them, creating us after his own image so that we could share in his own thoughts. So there's that famous phrase that is very frequently paraphrased when Johannes Kepler is quoted. So you see the idea. I have the phrases highlighted in yellow here. Laws, figures, and relations. So he's referring to the mathematics that describes the physical universe. And then he goes on to say, those are within the grasp of the human mind because we are made in the image of the Creator, in whose mind the eternal rational plan of the cosmos has existed from eternity. He says, our understanding is in this respect of the same kind as the divine, at least as far as we are able to grasp something of it in our mortal life, for the divine counsels are impenetrable, but not his material creation. So the reason I have this first line highlighted in yellow is because we're going to see a very similar statement with someone that you have all heard of in just a moment. Our understanding, our rationality, our mental life being the same kind as God's, not in magnitude, but just in kind. And then he goes on at the end of this and he says, the material creation is not impenetrable, meaning there is a lot that we can learn from studying nature. And through the study of nature, we therefore learn things about the very mind of God. In his Mysterium Cosmographicum, or the Mysteries of the Cosmos in translation, he says, God the Creator had the mathematicals with him as archetypes from eternity, which is just a lovely poetic way of saying the mathematics of the cosmos has existed in the mind of God from eternity. All right, so here's the diagram that I promised you earlier. This is Kepler's metaphysical framework, aka Kepler's natural theology. So at the top of the triangle, I have the word archetype, the word that Kepler just used in the quote that I gave you. This is the idea of the immaterial mathematical plan for the creation existing in the mind of God from eternity. If you go counterclockwise, you come to the word copy. That's our natural world. This is the copy of the archetype in tangible form that when we do science, we get to examine. And then if you keep going, you come to image. And you see in parentheses there, I have humankind, meaning humankind made in the image of God, so that we can regard the copy and discern something about the archetype. We can think God's thoughts, to paraphrase Kepler. Kepler's contemporary, you know this guy, Galileo Galilei, made this comment, famously actually. He said, this all-encompassing book that is constantly open before our eyes, that is the universe, is written in mathematical language. Okay, I know you guys are all much younger than I am, but I'm going to ask this question anyway. How many of you have seen the old 1950s Disney feature film called Donald in Mathmagicland? Anybody? No, this is the first time no one has seen it. Okay, go to YouTube today and type in Donald in Mathmagicland. It's a Donald Duck cartoon. It's about 25 minutes long, where it actually spells out in wonderful animation a lot of the concepts that I'm talking about today. But the reason I bring it up is because the very end of Donald in Mathmagicland, remember, this is the 1950s when Disney was a very different company than it is today. This quote comes up on the screen. And then it actually says that God has had these mathematics in his mind from eternity. It's a really interesting piece of history for you there. Okay, now, as I promised, a guy that all of you have heard of, Sir Isaac Newton, he's making here a statement very similar to the one you saw from Kepler, where Kepler says that our minds are the same in kind, our rationality is the same in kind as the mind of the Creator. In his unpublished scientific papers, Newton says the analogy between the divine faculties and our own is greater than has formerly been perceived by philosophers, that we were created in God's image, Holy Writ testifies. So I'm going to pause here and just remind you where we've come from in this intellectual history. We started with a pre-Socratic philosopher, Pythagoras, and we've come all the way to Sir Isaac Newton, and we're seeing these exact same themes, that there is an underlying mathematical rationality behind the cosmos, and that something about the mind of human beings is in resonance with this mathematical rationality. And as this tradition has become fused with Christian thought in guys like Kepler and Galileo and Sir Isaac Newton, and even we saw well before them, St. Augustine of Hippo, we're seeing these same exact themes. Now we're going to make another leap forward and take a look at a few Nobel laureates of 20th century physics. We will begin with Max Planck. So Max Planck was at the University of Berlin. He won the Nobel Prize in 1918, and he is regarded as the father of quantum theory. So that's the field of physics that deals with how matter and energy behave at the subatomic level, well, the atomic and the subatomic level. And what Planck was famous for was his theory that energy exists in little individual units called quanta instead of continuous waves. But the wonderful thing about Max Planck is that he had a very deep conviction that science and religious faith are compatible, but he also recognized this resonance between the rationality of the material world and the mind of man. And from his work entitled Scientific Autobiography, he says the following: "My original decision to devote myself to science was a direct result of the discovery which has never ceased to fill me with enthusiasm since my early youth, the comprehension of the far from obvious fact that the laws of human reasoning coincide with the laws governing the world about us." So he admits here in this essay that this is the very reason he devoted his life to science. Just like Johannes Kepler. It was this, what I often call this grand cosmic resonance that intrigued him and held him captivated, just like it did Kepler for his entire career. You all know this guy, Albert Einstein. So we now come to our first, I guess we could call Einstein an agnostic. I'm going to use that term very loosely. He was absolutely not a theist. He rejected labels having to do with religious faith altogether. He's been quoted in various articles. There are interviews where he says, "You can't call me an atheist, you can't call me an agnostic," but he often admitted to having fondness for a Spinozan flavor of deism, but he was really just all over the place. There are some who even believe that when Einstein used the word God, he did not mean God in the sense that we would typically use it, that it was really just a colorful metaphor for the rationality of the cosmos. But one thing, like many of the great thinkers before him, held him intellectually captivated, and that was cosmic comprehensibility. And in maybe 3 or 4 different places, newspaper interviews and private letters, he said the fact that it is comprehensible is a miracle. Einstein, as you can see here on my slide, he won the Nobel Prize in 1921. But I want to give you a short excerpt from a letter that he wrote to an associate in 1952. "The success of such a project," and here he means applying mathematics to nature, "presupposes a high degree of ordering of the objective world," meaning nature, "and this could not be expected a priori. That is the miracle which is being constantly reinforced as our knowledge expands. And again, he remarked on the intelligibility of nature repeatedly, and he never came to a satisfactory conclusion on the reason why nature is so thoroughly mathematical and we have the intellects to discern many of nature's great mysteries. Two more Nobel laureates. Paul Dirac won the Nobel Prize in 1933. He says God is a mathematician of a very high order, and he used very advanced mathematics in constructing the universe. Okay, for Dirac, the word God is a metaphor for the rationality of nature. He was not a believer in God. Then Wolfgang Pauli, Nobel Prize 1945, he said, we must postulate a cosmic order of nature beyond our control to which both the outward material objects and the inward images are subject. So by outward material objects, he means the tangible stuff of nature that we examine when we do science. And by inward images, he's really talking about the abstractions in our minds, the mathematical laws of nature and so forth. So we're seeing our Pythagorean Platonic tradition even into the mid-20th century. And then we come to a very curious character. This is Eugene P. Wigner, won the Nobel Prize in 1963. He was a theoretical physicist, engineer, and mathematician. He was the founder of the field of nuclear engineering. So if any of you have heard of him, that's probably the context in which you have. He was part of the team that developed the very first nuclear reactors. So Wigner grew up in a secular Jewish family, just like Albert Einstein did, and he was what I would call a practical atheist. He wasn't hostile to religion, but he also did not find arguments for the existence of God to be compelling. He writes about this in his autobiography. But in 1960, he published an essay. This is free online. It's only about 4 pages when you print it out, and it's entitled The Unreasonable Effectiveness of Mathematics in the Natural Sciences. You do not have to be an expert in physics or philosophy to appreciate this essay. I highly recommend that you make note and find some time to read through it, because it's just chock full of wonderful quotations like these. He says, the enormous usefulness of mathematics in the natural sciences is something bordering on the mysterious. There's no rational explanation for it. It's not at all natural that laws of nature exist, much less that man is able to discover them. So notice what he's getting at here. He's getting at this cosmic comprehensibility that all of these great minds of the Western tradition have attributed to the fact that there is a rational creator in whose image we are made, but he's chalking it up to mystery. And he is not the first one to do that, and nor was he the last. So we'll springboard forward again to the contemporary conversation, and I will start with Sir Roger Penrose, who won the Nobel Prize in 2020. He's perhaps best known for his collaborative work with the late, great Stephen Hawking. I will tell you that I am far from alone in what I'm about to say, so this is not just my personal opinion. Roger Penrose is far more of a great intellect than the late Stephen Hawking, and he is far more responsible for a lot of the work that Stephen Hawking actually usually gets credit for. And so there's just a little bit of science history trivia for you there. So Roger Penrose is not a theist. He would probably describe himself, if you tried to pin him down on it, he would probably describe himself as an agnostic. But like Einstein, like Eugene Wigner, he has wrestled with the mystery of cosmic comprehensibility for most of his career. In his book, The Road to Reality, he says, there's an extraordinary concurrence between the workings of the natural world at its most fundamental levels and sophisticated mathematical theory. He goes on to say, it makes no sense to me that this concurrence is merely the result of us trying to fit the observational facts into some organizational scheme that we can comprehend. The extraordinary concurrence between nature and sophisticated, beautiful mathematics is something that is out there, he says. So he's chalking this up to some sort of grand cosmic mystery. Now, in his publications, in a couple of his books and a couple of his published scientific papers, he uses this diagram. And I want to walk you through this because I think he perfectly captures the metaphysical problem that we're dealing with when we talk about cosmic comprehensibility. So at the very top of this triangle, you see a circle with some mathematical equations in it. Penrose refers to this as the Platonic mathematical world. So he is a thoroughgoing Platonist, so think back to what I was talking about earlier this afternoon about the doctrine of Platonic forms, these abstract mathematical operations just existing out there in what some people call the Platonic heaven. So Penrose acknowledges this realm of Platonic mathematical forms. And then if you go clockwise around this diagram, you come to the physical world, the bottom right-hand triangle. And in that circle, you see all sorts of material things, galaxies and planets and tables and plants. So the reason there is this cone shape that connects the top circle to the right-hand circle is because Penrose says there's only a teeny tiny bit of that Platonic mathematical world that is necessary for unlocking the mathematical laws of nature. So it's just a tiny bit of that Platonic realm that we press into service for the sciences. And then if you go to the final circle there on the bottom left, we come to the mental world. And again, it's just a small part of the physical world that then gives rise to the mental world, namely the human brain. So Penrose says, all of our mental world should ultimately be explainable by neuroscience. So in principle, it hasn't, but in principle, he says, it should be if there is no immaterial soul. And then it's a small part of that mental world that in turn brings us back to the top that can grasp these abstract mathematical concepts. And so we just go around and around and around, and we need some sort of metaphysical explanation for why we have this resonance of mathematics, matter, and mind. So what would the naturalist typically say to all that I've presented to you so far this afternoon? Well, one common claim is that the reason this works out so well is that humans have merely devised systems of mathematics to fit the natural phenomena closely enough. The idea is, it's like when you sew a glove to fit a hand. It's just not really that surprising because you used a pattern based on the hand to get the glove. But I want to offer a couple of rebuttals to this idea. Okay, rebuttal number one is that it turns out that some of the mathematical systems in question were actually developed independently, meaning these mathematical systems had no real-world application when pure mathematicians developed them sheerly for their beauty and elegance. And I'll give you an example here. So this is Kepler's first law. Don't worry, you don't need to understand all of the algebra there. But the point I'm making with this diagram is that we have all of this mathematics involved with explicating the different dimensions of this particular geometrical shape. And these were instrumental in Kepler developing his laws of planetary motion. However, all of these mathematics predated Kepler's work by centuries. We can trace it back at least as far as Apollonius of Perga in the 3rd century to 2nd century BC in his work entitled Conics, which actually used to be included in the official Great Western Canon, but then it was removed, I don't know, like back in the 60s or 70s, I think. I have no idea why. But anyway, you can see this diagram here, all of these different conic sections, and the ellipse is the second one down, the one in green. So Apollonius developed a lot of the mathematics associated with the ellipse, meaning there was a mathematical tool ready and waiting for Kepler when he was ready to use it. The famous mathematician and historian of mathematics, Maurice Klein, says the following. I think this is a really interesting point. He says it's unlikely that Kepler would have invented the ellipse, meaning all the mathematics associated with the ellipse, to describe planetary motion, because of that task, together with the one he actually performed of fitting the ellipse to his data, would have been superhuman. So you need to think about the fact that Kepler, Galileo, Isaac Newton, they were making their dramatic discoveries about the cosmos with dip pen and paper. There were no electronic calculators, much less computers or AI at their time. So that's why Klein says this would have been a superhuman feat. Imagine the years and years of labor to work out a mathematical system, and then the years and years of labor to apply that mathematical system to a theory of astrophysics. It would have been a superhuman feat. But happily enough, the mathematics was there and waiting for Kepler when he needed it. A similar thing happened with Einstein's theory of relativity. So according to Einstein's theory, gravitational force is actually the result of the curvature of space-time around massive objects. And so as you can see from this diagram, the more massive the object, the more curvature you have in the fabric of space-time. Now, when Einstein was working on this, he needed a form of geometry that could describe curved surfaces rather than Euclidean geometry, which only describes flat planes. And lo and behold, it turns out that in the century before Einstein was working out his equations, a mathematician by the name of Bernhard Riemann had developed a geometry system that was exactly what Einstein needed for his theory of relativity. Maurice Klein says, Einstein took full advantage of the already existing non-Euclidean geometry to create the theory of relativity, whereas the invention of an ingenious new geometry and applying it to a radically new physical theory would have been beyond the powers of one man. So again, the same idea, this superhuman, beyond the powers of one man kind of situation. This is Steven Weinberg. He is a late physicist and professor of physics from UT. He won the Nobel Prize in 1979, and he was an ardent atheist. He was more than an atheist. He was anti-theist, very aggressive about his anti-theist views. But even he admitted it's positively spooky how the physicist finds the mathematician has been there before him or her. So he's describing this exact phenomenon that I've just presented to you, the fact that you'll have pure mathematicians who develop these mathematical theories for the sheer intellectual beauty of them, and then much later, sometimes much, much later, all of a sudden there is a perfect scientific application for this mathematical system. And it strikes him as very mysterious. In his book, Dreams of a Final Theory, he says, physicists generally find the ability of mathematicians to anticipate the mathematics needed in the theories of physics quite uncanny. So spooky and uncanny, he calls it, mysterious. Okay, so a second rebuttal we could offer for this idea that, we're just inventing the mathematics that we need for the sciences is that there are many cases in which mathematics maps onto the material world with such an astounding precision that it's even made successful predictions And these predictions have been in fields that actually involve delicately balanced systems of equations. And I'm going to give you one example. I know we're getting close to the end of our time together. Scott, do I have until 20 after? Okay. So this is Dr. Peter Higgs. He just passed away in 2024. He won the Nobel Prize in 2013. This is Peter Higgs in the 1960s. Okay, so let me tell you the story of Higgs field theory. So back in the 1960s, Peter Higgs and several of his colleagues were working on the problem of how subatomic particles get their mass, specifically the quarks that make up protons and neutrons in the nucleus of an atom. So at the time, the standard mathematical model that they were working with would be thrown into complete disarray, like chaos of mathematics, when they tried to plug in a number to represent the mass of subatomic particles. And they were convinced, just based upon the beauty and harmony of the model when the mass was allowed to remain zero, that surely there must be a way to maintain this harmony and beauty. And so Peter Higgs and some of his colleagues said, well, what if subatomic particles get their mass by interacting with some sort of invisible field? That way, we could leave our value in our equations at zero, but then we need a mathematical theory to describe the field with which these particles are interacting. So many did not like it. There was zero empirical evidence for the Higgs field, but they went with it because they were so driven to maintain this beautifully coherent, elegant, standard model of particle physics. Then we can fast forward half a century later, half a century of Higgs field theory just being used as the working theory of particle physics. And CERN, here, this is a picture of the inside of the Large Hadron Collider, was able to test Higgs field theory. And on the 4th of July, 2012, they announced that a particle fitting what they call the Higgs boson, or the kind of particle we would expect to be flung off if there is in fact a Higgs field that permeates all of space, had been detected. And so essentially, Peter Higgs' mathematical theory 50 years before had predicted the existence of a field permeating all of space. And so that's what I mean when I talk about mathematics often predating and mathematics fitting onto nature so precisely and elegantly that it has even made predictions. This is a picture of Peter Higgs. I love this picture of him so much because I can just imagine the vindication you would feel after 50 years of telling people. So there he is in front of the Large Hadron Collider at CERN. And then here he is with the late Stephen Hawking. And Stephen Hawking fought Higgs field theory his entire career up until the empirical evidence was discovered in 2012. And so because he had famously opposed the theory, he was interviewed by quite a few publications after the fact. And here's what he said to one of the reporters. "Physics would be far more interesting if it had not been found. Congratulations to them both, but the discovery of the new particle came at a personal cost. I had a bet with Gordon Cain of Michigan University that the Higgs particle wouldn't be found, and that Nobel Prize cost me $100. All right, so another naturalist claim, and I'm going to go through this last part pretty quickly. As I mentioned before, I do elaborate on this in my book on Kepler, but the claim is that unguided evolution of the human brain has produced the capacity for advanced mathematical computations. So it should not be surprising to us that we are able to do the kind of math that fields such as particle physics use. But a good rebuttal to this claim is that the cognitive capacity necessary for advanced mathematics seems far beyond the alleged powers of natural selection. And I'm not going to read you the following quotes, but I want you to see the faces and the names. This is Paul Davies. Paul Davies is not a believer in God in any traditional sense. And in his book, The Mind of God, he talks about how it's really far from clear how these kinds of abilities to do advanced mathematics could have evolved by natural selection. And then our great Christian philosopher, Alvin Plantinga, in his book, Where the Conflict Really Lies, which is a fabulous book, he talks about this at some length. He has part of a chapter is actually devoted to this idea that it's completely unreasonable to expect a mechanism like natural selection giving us the ability to do advanced mathematics. And then our second rebuttal would be that material processes alone cannot account for human rationality. And here are just 3 reasons we could give for that. First of all, a brain event is just an instance of material cause and effect, meaning we have no free judgment. Our neurochemical reactions cannot adhere to laws of reasoning, meaning like the laws of logic, the laws of math. And neurochemical reactions cannot be about anything. In philosophy, we call this the problem of intentionality. So if your neurochemical reactions can't be about anything, rationality actually turns out to be impossible. I'm going to skip through our Sean Carroll quote there. So that just brings us back to the original problem. Well, it's not a problem if you have a Keplerian natural theology, and that is the resonance between mathematics, matter, and mind existing in harmony. And just to show you the diagram of Kepler's metaphysical explanation one more time: archetype, copy, and image. And I would just like to close now with a poem, short poem written by Kepler himself about this very harmony. As God the Creator played, so he also taught nature as his image to play, the very game which he had played before her. Thank you so much.